All right, let's solve this guy right here. The square root of 3x minus 5 is equal to 4. Think back to the steps that we told you for solving radical equations. What's the first step? Get the radical by itself. So what do I need to do?
The radical is by itself.
The radical is by itself, right? The radical is the whole thing with the 3x minus 5 in it. You better make sure that your square root symbol goes as far as it's supposed to. So the radical is by itself. Step 2 says use the power property. That means I have to raise both sides to the same power. So what's the power?
It's 3x minus 5.
It's the second power, so I get what on the left side?
16.
3x minus 5 is equal to 16.
Then
Now, is this quadratic or linear?
linear.
It's linear. So
3x equals 16 plus 5 is 21.
move the 5 over, I get 3x equals 21, which means x equals how much?
So 21 minus 7, minus 5 is...
Right, so you're checking your work right here.
That'll be 21 minus.
I've got the square root of 3
9.
times 7 minus 5. Does that equal 4? Okay, that's what I'm checking. So I have, and when you do this neatly, because I've seen way too many students get crazy with their radical,
Yeah, that's
and your check work is atrocious. So 21 minus 5 is inside the radical, isn't it? So this gives me
16.
the square root of 16, which equals what?
4. That is true.
So you see that it does check out. Okay.
And you're saying that it won't always be true, you're saying?
Sometimes we have issues because the limitations on the radical sign only return the positive square root. Okay. And if this only returns a positive, what if I had the square root of 3x minus 5 equals negative 4? Could the square root equal a negative number?
Mm-hmm.
The square root by itself would not return a negative because...
What about the minus on to it? Oh, it still would be minus. It still wouldn't do that. Oh, so would that be not real numbers again?
it would be no solution.
Solution.
And you know what? Just
No, oh yeah.
hold on. If you were to graph this, okay, you can solve equations by typing in the left side of the equation for one of your y's, type the right side of the equation for the other one. When I hit graph, I'm looking for where these guys intersect. Do you see these guys have an intersection point?
X equals 7.
And I bet that's right there when x equals 7. Let me change my zooming window. So there's that guy, and here is y equals 4. And I see them intersecting right here, which looks to be right at x equals 7. Do y'all agree? So that's verified. Okay. You could also do second trace to calculate the intersection point right here. First curve is good. Oh, you're not going to be happy till I get on here. First curve, second curve, my guess, and it tells me that x equals 7. So I know that x equals 7 is my solution. Perfect. Well, let's try another one. Because I think you guys are feeling it. I'm feeling it. I'm in the groove. The cube root of 7 minus 2x plus 10 is equal to 3. Follow those steps I gave you for solving these. What will you do? Isolate the radical by subtracting the 10. So when I do that, I have the cube root of the quantity 7 minus 2x is equal to what? That's negative 7, right? Apply the power property, and I've raised both sides to the appropriate power. In this case, like you're saying, Chris, it's the third power. So what do I get on the left side? All I get is 7 minus 2x, because the cube and the cube root will reduce with each other. And negative 7 to the third, I saw you already flipping to your powers. What'd you come up with?
343.
Negative though, right? Negative 343. All right. Move the 7 over. So negative 2x equals how much? Right, negative 350, divide both sides by negative 2. So x equals what?
175.
X equals 175. Okay. Now, just so you guys are aware, most of the time when you're dealing with cube roots, you shouldn't run into extraneous solutions. You really shouldn't. Square roots, you may, because of the way that it's constructed, the way that cube roots, or the way that square roots work. So I will say that x equals 175 is true, and I will let you guys check that on your own to verify that that does work out when you plug it into the original equation. Any questions about this?